Vectors is one of the final topics on a GCSE paper, and as such is quite difficult to get your head round. One way of thinking about it is if you're programming a robot. So if we've got Arne here as a Terminator, we could give him a direction to go from a house to a church. But it's quite difficult for a robot to know what a house is and what a church is. We take it for granted, but if we look on the right hand side here, this thing at the top is a house, as is this thing at the bottom. But they look very, very different. What robots can do, however, quite easily is turn a certain amount and walk a given number of steps in that direction. And that is how you should think of vectors. What we've got here in a typical exam question is 4 points. We've got O, R, Q and P. They're like the locations, they're like the church or the house that the robot can't see. What the robot can do though is do a movement. So this 2A here is the move from O to P. And the 2B is the move from O to R. Because it tells us it's a parallelogram, we should be able to see that the move from O to P, which is this thing 2A, is exactly the same movement as the one from R to Q. So that's also 2A. And also, we should be able to see for the same reason that that one at the top, that movement from P to Q is 2B. So, let's have a look at the question. It generally wants us to use all the information. We've kind of used the parallelogram information, and we're probably going to have to use this midpoint information in a minute. So it says find the vector px in terms of a and b. So px, let's highlight it on our diagram, is in orange there from p to x. We know that x is the midpoint of pr. So it follows that px, we write it like that, is equal to half of pr, because it's halfway. So really what we need to do is find pr. So let's do that up here. Let's plan a route out. The computer or the robot doesn't know what P is and it doesn't know what R is, but it does know how to do the vectors. So our route is going to have to use the vectors A and B that we actually know. So let's plan a route. Let's go from P to R, we're going to go from P to O and then O to R. So let's write that out. P to O plus O to R. That's our route. Then we're going to substitute in what we know about this P to O bit, which is that it goes from P to O, which is in the opposite direction as 2A, so minus 2A, because it goes against the arrow. The O to R bit goes with the arrow, so that's going to be a plus 2B. All we then do is, down here, we're going to put a half of PR, which we've just worked out, and use our algebra skills to expand that bracket and get minus A plus B. That's the first part. The second part is quite tricky. It says prove that x is the midpoint of OQ. So x is in the middle, OQ is that bit all the way, and it wants us to say that prove that x is in the middle. What the approach we're going to take then is we're going to look at OX and we're going to look at XQ, and if they're the same, then it follows that x is in the middle. So if this first bit is the same as the second bit, then x must be in the middle. So OX first, let's have a route for OX. O to X, we're going to go from O to P first, and then we're going to go from P to X. Notice that we're using what we found in the first part of the question, and this is very common with vectors. We're going to have to use what we did in part A in part B. O to P is 2A. P to X, we found in the first part, is minus A plus B. If we tidy that up, we've got 2A take away A, which is A, and we've just got a B, so we've got A plus B. We're underlining because we can't really do bold using pen and paper, so we underline to show that they're vectors. XQ is, we're going to go from X to P, and then we're going to go from P to Q. X to P is P to X but backwards. So it's going to be the opposite of the bit we found in part A, which was, remember, this bit here, that P to X is minus A plus B. So x to p is going to be the opposite. It's going to be plus a minus b. And then the pq bit is just plus 2b. Again, tidy it up. We've just got 1a, and we've got minus b plus 2b, which is plus b. And therefore, we have found what we wanted. At the end, we know that the journey from O to x is a plus b, and the journey from x to q is also a plus b. And therefore, they are the same, and thus x must be the midpoint of OQ.